Hey guys, today we're gonna keep going with one of the coolest concepts in calculus, which is derivatives, okay? In the previous videos, we showed what the hell a derivative is, and why, well, it's something pretty cool to see. And today we're gonna be doing some problems and, just playing with the definition of a derivative, okay? So you get the hang of, what we're actually doing with all those, with all that algebra, basically, okay? So let's dive into it. So now, before we start with the problems, let's recap what we learned in the last videos. So we know a derivative is basically if we have a function and we have 2 points, and there is like a curve between those 2 points, we want to bring together those 2 points so we can find a infinitely small slope between them, between those 2 points. And that slope, well, we simply say that the limit as h, the distance between those x points that we're playing with, is approaching 0, okay? So what I want to do right now is basically find derivatives using the definition so you get the hang of what we're actually doing, okay? I think one of the best ways to practice is basically doing problems and see, oh, this works this way, or, oh, well, you can't do that because this, and that. I think that's something pretty useful. So now, in the last video, we found the derivative of x squared. Now I want to show you the derivative of, well, let's say something more complex. Let's say we have f of x. Now, I'm not going to say f of x, right now I'm just going to say f. So we have that f is just simply going to be 2x squared, okay? Basically, this would be a parabola, but like a bit compressed, okay? The values or the y values would go twice, they would go twice as high for a simple change in x, okay? So now, what is the derivative of this? Remember that the definition of a derivative is basically this equation. The equation that all of you know from when you started algebra for a slope, okay? This is the same as if you said that we have a function f of x and we're bringing it basically, we're adding just a little bit to that function. So we say f of x plus h. This would be like our y2 value minus our smaller y value, which is f of x, and all of this divided by h, okay? This is technically x plus h minus x, but we know the x's are just gonna go out, so you get h. Now this is the definition, and this is missing, of course, the limit as h is approaching 0. And we're going to apply that limit to this function. So let's do it. We would have that f prime is going to be equal to the limit as h is approaching 0 in the function, so we have 2h squared. Now, this would be the same as if we had 2 times x plus h, okay? The input that you have, you're just going to add just a little bit to that input. That is what we have here, or what this means. You have x, your input, and you want to add just a little bit to that input. And then you're going to square whatever you get from that addition. Minus our y1 value, so f of x, 2x squared, and all of this divided by h. Okay, now let's find its limit. So should I expand? Yeah, I'm going to expand that. So we're going to get 2 times x squared plus 2x times h plus h squared minus 2h squared h. This is going to be equal to, so we can distribute this. And in this case, real quick, we would get 2x squared plus 4h times x plus 2h squared. Now we know these two terms, this one and this one, they're gonna go out, and so we get 4x times h plus 2h squared divided by h. Now this is just algebra. You can see this is the limit as h is approaching 0. You can't plug in h, but you can take out the common factor. So you're gonna have h times 4 times x plus 2 times h divided h. And this is just going to be equal to 4x plus 2h. Now we can compute that limit. as 4x plus 2h. Now we can plug in that, so we would get that. We know this is just simply going to be 0. We get a product of 0. And so f prime, this limit is going to be equal to 4x, okay? It's pretty simple, and now this makes absolutely a lot of sense. Do you remember that I said that since we are multiplying by 2 and the outputs that we have for x squared, and so the function is instead of, let me show you, so just the positive part, so you would have something like this for x squared and something like this for 2x squared, okay? You basically have like a more compressed function because the values are gonna go up even more or twice as much because we're multiplying by 2 than if we had 2x, I'm sorry. And now this makes a lot of sense because the f prime for x squared, we know if we have f of x is equal to x squared, f prime, remember the last video, is going to be equal to x. And now this f prime for 2x squared is going to be twice as big as for x squared, just with no coefficients. So basically, this is showing you that this coefficient is making the slope twice as steep, okay? I hope you see what is going on here, okay? It's pretty cool. And so, well, this is pretty cool, and you can see, I think this makes sense, okay? I hope you're seeing what I'm saying, okay? If we have 2 times the outputs that we're getting with x squared, the derivative or the slope for this function x squared, or for the function x 2x squared, is going to be twice as big because we're multiplying by 2 than the derivative of f of x, okay? So this is basically what I'm trying to show you, okay? So I'm gonna do some more examples so you see what I'm, well, just to get the hang of all these derivative things, okay? So now let's do one more example with this function right here. In this case, we have 2 terms. We have x squared plus 1. Don't worry about the plus 1, you're gonna see what happens with it, okay? So let's do the definition. So we know f prime, in this case I'm gonna start down here. F prime, remember f prime is the derivative of f, is going to be equal to, so we have x plus h squared plus 1, and all of this, minus the initial function, squared plus 1, and all of this divided by h. And now, oh, I actually missed the limit. Well, now let's solve these, let's solve what we have here, okay? So in this case, we could expand that. We know how much that is going to give us. So we're going to have that this is x squared plus 2xh squared plus 1 minus x squared. Now just distribute the sign minus 1. And all of this is going to be divided by h. Now what can we cancel here? You can see that now maybe you see a pattern. X squared most of the times is going to cancel out with x squared. So we're gonna get up here. Let's see how much we get. And also, so these 2 terms, they're gonna go out, and also positive 1 and negative 1, and we're gonna have what we had before. So 2xh. Well, what we had before, I mean what we had in the previous video of x squared. And now, well, you know how to solve this. It's pretty simple. So now you say the limit as h is approaching 0 in the function 2x times h plus h squared divided by h. You take out h, and now this is just going to be 2x plus h, which is just simply going to be 2x. Now you might be wondering, and of course, well, isn't this the derivative of x squared without any other term? And yes, of course, you're right, but there is something pretty interesting. The derivative of any function that has a term is the same derivative that if it didn't have any, that has a term that is a constant, so, or that has, you could say, x to the 0th power, which is just 1 times 1, which is just simply 1. So any function that has a derivative with a variable and a constant or a term that has x to the zeroth power is going to be the same derivative as it had no other term, okay? So I hope you see why is that. We just computed the derivative of x squared plus 1, and well, turns out it is the same derivative as x squared, okay? So if you have a function that has a variable and a constant, imagine the constant is not there, and well, you can differentiate. Differentiate is the verb that we use when we're saying or when we're referring to the action of finding a derivative, okay, or computing this limit. So I hope you guys enjoyed this video, maybe get some more the hang of well, what we're doing here with derivatives. In following videos, we're gonna keep solving more derivatives using the definition, okay? And in later videos, we're gonna be using some other tools that we have, such as differentiation rules, which are pretty effective. But for now, we're gonna keep going with the definition, okay? So see you guys in the following video and have a nice one.